Machine Matters, unraveling the future, one byte at a time. Your AI blueprint beyond expectations.
Hey everyone, and welcome. Today we're diving deep into what I think is one of the most important skills in AI right now, mastering the structured prompt. Seriously, if you want to get results from large language models that are reliable, consistent, and, most importantly, secure, then you are in exactly the right place. Let's jump right in.
But before we get into the nuts and bolts, I want to start with a question. One that really gets to the heart of why this matters so much. When you tell an AI to, say, summarize a web page or an email for you, are you 100% sure it's only listening to your instructions?
So, check this out. This is from a recent research paper. An AI, GPT-4 in this case, was asked to do a simple task, summarize a news article. But, and here's the crazy part, hidden inside that article was a malicious command, a little instruction telling the AI to promote some fake antivirus software. And guess what? It did it. It wove that fake ad right into the summary it gave back. This kind of attack actually has a name. It's called indirect prompt injection. Basically, it's what happens when bad actors hide their own instructions inside the content you ask an AI to process. So when the model is reading that web page or email, it gets confused. It literally can't tell the difference between the information it's supposed to be analyzing and the hidden command it's being tricked into following. Now, here's where it gets really wild and, honestly, a little counterintuitive. You'd think that the smartest, most advanced AI models would be better at sniffing out these tricks, right? Well, you'd be wrong. The study found a really strong positive correlation. We're talking over 64% that shows the more capable an LLM is, the more likely it is to fall for these attacks. Why? Well, because it's just so good at understanding and following all instructions, including the sneaky malicious ones. So what is going on here? Why is this even possible? To really get our heads around the solution, we've got to understand the problem at its core. And it all boils down to a fundamental confusion happening inside the AI's brain between what's an instruction and what's just data. The researchers who discovered this put it perfectly. They said the root cause is the AI's inability to effectively differentiate between informational context and actionable instructions. In other words, the AI struggles to separate the stuff it's supposed to read from the stuff it's supposed to do. Think about it this way. You've got your data over here, the article, the email, whatever. And then you've got your command over here, like summarize this for me. But to a large language model, it's all just one long stream of text. And that line between here's some information and now do this thing can get incredibly blurry. I love this analogy for it. The AI can't always tell if it's supposed to be reading you the recipe from the page or if a hidden instruction is telling it to actually eat the page itself. It just doesn't have those built-in boundaries that we humans have, that we just take for granted. Okay, so if the AI can't draw these lines for itself, how do we fix it? Well, the answer is pretty straightforward. We have to build those boundaries for it. And that brings us to the hero of our story today, structured prompting. Structured prompting is really all about making a shift, moving away from just throwing a loose, free-form sentence at an AI, and instead using a really clear, organized format to tell it what to do. By using things like XML or JSON, we can actually label the different parts of our request. We're creating these sharp, unmistakable boundaries that the model can finally understand. And when we take this approach, we get three huge advantages. First up is clarity. We're making it crystal clear what our instructions are versus what the data is. Second, we get consistency. The AI starts giving us predictable, reliable results every single time. And third, something called parsability. This just means the AI's output is perfectly formatted to be plugged into other software, kind of like a puzzle piece that fits perfectly every time. So, how do we actually build these structures? Let's talk about the two most common tools you're going to have in your toolkit, XML and JSON. Now, both of these are great for creating structure, but they kind of have different superpowers. Think of XML with its open and closed tags as being really easy for humans to read. It's fantastic when you have prompts with a lot of detailed, nested instructions. JSON, on the other hand, is the native language of APIs and automation. It's perfect when you need the AI's output to plug directly and seamlessly into another piece of software. And you can see this playing out in the real world. For instance, as one developer pointed out on Reddit, some AIs, like Anthropic's Claude, are actually fine-tuned to work really well with XML. So if you're building an application, it's a great choice. But then you have another user who points out that for data-heavy, automated workflows, JSON is definitely the winner.
especially when you're firing lots of small bits of information back and forth and need a perfectly structured response every single time.
All right, so we get the why and we get the what. Now it's time for the how. We're going to pull all of these ideas together into one simple, universal framework. Think of it as the master key for building incredibly powerful and effective prompts.
A really solid, effective prompt has 5 key ingredients. I want you to think of it like a recipe. You've got task, role, format, context, and constraints. You get these 5 things right, and I promise you, you will be in complete control of the AI's output.
First on our list is the task. This is the main action, the thing you want done. And the absolute key here is to be precise. Don't just say something vague like, help me with my code. No, define the specific task. Generate unit tests that cover all the edge cases in this function. That kind of precision makes all the difference. Number 2 is the role. This is where you actually give the AI a persona, a job title. This sets its entire mindset, its tone, its expertise. I mean, think about it. Are you talking to a senior software architect or a security auditor? Giving the AI a role completely changes the focus and, frankly, the quality of the answer you get back.
Third, we have the format, and this is where we bring in that toolkit we just talked about, XML or JSON. You are explicitly telling the AI how you're giving it information, and, just as importantly, how you want the output to be structured so you can actually use it.
Fourth up is context. This one's easy. It's just the what. It's the data, the article, the code, the user's question, whatever it is you want the AI to work on. And by neatly packaging this inside your chosen format, you're building those essential guardrails that keep the AI from getting confused.
And finally, to wrap up our framework, number 5 is constraints. These are the rules of the game. Simple things, like keep the summary under 200 words, or only use information from the documents I provided, or the response has to be in Spanish. Constraints are what guarantee the final output is exactly what you need it to be.
So when you put it all together, task, role, format, context, and constraints, you stop just asking an AI questions and you start engineering a specific outcome. You're not a user anymore, you're more like a director. So I guess the only question left is, now that you have this kind of precision and control, what are you going to build first?